Welcome. Today we're taking on a second major theory of organizational safety and the causes and prevention of major technology accidents and system accidents. And this is the theory of high reliability organizations. You'll be reading a couple of important texts on this topic in the next couple of weeks. First, the book by Scott Sagan, The Limits of Safety, which we're discussing this week. And then in 2 weeks, we'll read the book by Wyke and Sutcliffe, Managing the Unexpected. And Wyke and Sutcliffe are professors at the Ross School and major contributors to the theory of high reliability organizations. The basic idea that we're exploring here is the understanding that normal accident theory sets out an important challenge for us in the modern technology world. Accidents happen, and they are much more likely to happen within the complex processes which exist in complex management systems, tightly coupled processes, and nonlinear interactions. And further, when accidents happen in activities that have the potential for creating great harm for workers or for the public, we would like to suppose that procedures and systems can be created that minimize risk and facilitate soft landings when failures occur. And the kind of processes that we've been talking about, and we'll talk about more, large chemical plants, gas plants, aircraft and the management of aircraft, military systems, nuclear reactors, and other similar systems. And so what we would like to be able to accomplish is that we would like to be able to design these systems and these organizational frameworks in such a way that they give rise to safe operations, vigilant management, and resilient systems. And furthermore, it is very intuitive, it is very natural for us to suppose that greater attention to organizational and system characteristics can improve safety performance. We can avoid large failures and we can protect the public. I say it as intuitive. It means really that we can identify causes and sources of accident, we can anticipate accidents, and then we can design procedures which protect against the possibility of major harm resulting from accidents of those kinds. And furthermore, we seem to have some examples of systems that embody all the characteristics of risk which Perot identifies, which have nonetheless demonstrated excellent records of safety and low levels of harm imposed on workers and the public. A group of management theorists have therefore put the sociological microscope on some of those cases to see if there are identifiable factors that these systems and organizations have in common. And the result is high reliability organization theory. Organizational researchers believe that they have identified a handful of characteristics which HRO organizations have in common, and they have a theory about how those characteristics contribute to safe operations and resilient operations. Scott Sagan refers to several important initial contributors to these theories, and we'll be talking about these ideas throughout. But the researchers who came to formulate the kind of original theories and ideas in high reliability organization theory studied very specific industries. They studied, for example, the management of toxic chemicals, nuclear power, recombinant DNA research, ozone layer depletion, and global warming problems. These are the topics which Marone and Woodhouse focus on. A second batch of problems are a second batch of organizational systems and technology systems, the FAA air traffic control system, the Pacific Gas and Electric Company, peacetime flight operations on 2 U.S. Navy aircraft carriers. And these are investigations carried out by the Berkeley group mentioned on the previous slide. And then Wildofsky considers nuclear power plants, the human immune system, and the FDA drug approval process. The premise of HRO research is that there are specific features or characteristics of organizations that are favorable to resilient, safe operations. Those features are thought to be the result of deliberate, iterative design. Favorable safety performance was, quoting Sagan, a systematic product of human actions, the result of a deliberate process by which risks are monitored, evaluated, and reduced. which makes the process of risk control a highly rational process. The organizational theory challenge is to identify those features and to facilitate their adoption in other industries and settings, and possibly to improve them further through the evidence of experience over time. Quoting again from Sagan, the common assumption of the high reliability theorists is not a naive belief in the ability of human beings to behave with perfect rationality. It is the much more plausible belief that organizations properly designed and managed can compensate for well-known human frailties and can therefore be significantly more rational and effective than can individuals. So what are some of the features which HRO theories have identified? There are 4 or 5 key features or core features. The most commonly cited is the idea that leaders and executives must place an unambiguous priority on the safety goals of the operation. Sagan puts this in these terms: the goal of avoiding altogether serious operational failures. We might parenthetically contrast this idea about leadership priority on safety with the actual behavior of both the FAA and Boeing executive management and corporate management in the case of the 737 MAX. Leaders need to have clarity about operational goals. If cost cutting and safety management are parallel operational goals, leaders need to be clear that safety trumps cost cutting. That would be one good example. A second major idea, a second kind of discovery of HRO theory, is what they regard as the need for redundancy. Redundancy of systems and subsystems, of devices, of processes, and of people. The people part is probably important. It's kind of analogous to the idea of cross-training, but that the idea that there shouldn't be only a single person in a nuclear plant who has the expertise to diagnose a certain kind of problem, that expertise and competence should be spread out over a number of people. There should be, again, under the topic of redundancy, there should be multiple independent channels of communication and decision-making. And it is noted that redundancy is costly, but it is crucial, according to HRO theory, it is crucial for safety in the face of unexpected risks. Another important discovery which HRO theorists believe that they have documented is the value of decentralization of expertise and authority within high technology, high risk organizations. There's a need for what Sagan describes as rapid and appropriate responses by experts to unexpected events. So there should be a degree to which mid-level leaders and mid-level operators and managers are empowered to use their own expertise to solve an emerging problem. This field of thought also emphasizes the importance of cultivating and developing the right kind of culture within the organization, a culture which is focused on safety. The effectiveness of efforts to create a pervasive culture of reliability throughout the organization, from top to bottom, from bottom to top. The whole organization should be led towards internalizing the goals and practices that support safety. Quoting Sagan, how can an organization ensure that lower level personnel will identify situations properly, behave responsibly, and take appropriate actions in crises? This is a key problem of organizational design and organizational management. And part of the answer, according to HRO theory, is to recruit, socialize, and train personnel to maintain a strong organizational culture emphasizing safety and reliability. Another important feature is the idea or the institutional characteristic of continuity, to maintain continuity of people, of expertise, of training, and of readiness. So maintaining training and readiness for crises is crucial to being able to respond to a crisis, even though it is difficult to manage in routine periods of action. It is interesting to me that organizations like hospitals and universities and other medium-sized and large organizations engage in periodic tabletop exercises to confront various kinds of emergencies. And the goal of that, of course, is to maintain training and alertness for appropriate organizational response when emergencies arise. Another hugely important characteristic is the characteristic of organizational learning. Learning about how the technology functions in practice, how the systems both work or fail to work, discovering and learning about the unexpected interactions which can occur within sub-parts of the system in question. But learning also about the workings of the organizational structure itself and its latent dysfunctions. And I myself, anyway, but I think this is true for Perot as well, believe that it's really very important for us to try to identify the dysfunctional arrangements which often exist within organizations. Part of learning is paying attention to near misses. So the fact that a few heat tiles were lost in flights of the Space Shuttle prior to the flight of the Space Shuttle Columbia, those might be regarded as minor maintenance issues, which is actually the way that they were regarded by NASA, or they might be regarded as a near miss of a catastrophic failure of the heat shield system and loss of the vehicle and crew. Learning from near misses is a hugely important part of maintaining and improving the safety and reliability of an organization. It is hugely important, according to HRO theory, to encourage full, honest reporting of accidents and near misses. And any organizational feature which discourages employees, managers, directors from reporting their own experience or possibly the experience of others around them, any such discouragement within an organization is antithetical to the goal of improving safety performance. In order to continue to enhance safety performance, the HRO theory emphasizes that simulations, tabletop exercises, and other ways of hypothetically analyzing how the organization can respond, should respond, or would respond in face of an unexpected crisis. This is another way of learning from kind of real world experience where the simulation has been set up in sufficient detail that it really does test the organization. And it is possible to design investigations by engineers and organizational specialists to do a kind of a theoretical analysis, hypothetical analysis of what the likelihood and what the process would be of a risky situation which is considered to be highly unlikely, but if it did occur, how would that affect the workings of the power plant or the nuclear reactor or the aircraft? So the direct topic of Scott Sagan's book is on the topic of a particularly important and large and complex organization, the organization in the United States which deploys, commands, and controls nuclear weapons. And it is kind of self-evident that no activity has greater absolute risk than those activities through which nuclear weapons are deployed, maintained, and controlled. An accidental release or firing of a nuclear weapon is catastrophic in itself, and it may have also the consequence of causing an escalation of war between two nuclear-armed states. So safety within command and control of nuclear weapons is crucially important. Sagan gives huge case study attention to several important nuclear political crises, international crises, including especially the Cuban Missile Crisis, 1962. But he also studies a couple of other near misses, a couple of other major accidents which have occurred in the U.S. command and control system, which gives him a very strong basis for evaluating the propensity for either safety or possibly for accident within that system. In fact, he regards this area as being a tough test for the two major theories of accidents that we've considered, normal accident theory and high reliability organization theory. Because nuclear weapons command and control has never resulted in an unintended detonation. We've never had an unintended explosion. But we have witnessed a number of near misses, weapons, both hydrogen weapons and fission weapons, which were dropped out of aircraft, which were dropped on the runway, never resulting in an explosion, but very alarming possibilities were raised by these cases. And so his question is, one of his questions, which theory provides a better understanding of the actual workings of this vast social, bureaucratic, technical, and military system? I find it a completely fascinating book, and I hope you found it equally absorbing. So the thought question is whether a high reliability theory can offer useful and usable recommendations for leadership training, organizational design, and management behavior. Are the 4 key findings or 5 key findings translatable into advice about designing and leading technology organizations in the future? And these priorities, remember, are leadership priority on safety, building redundancy, decentralizing decision-making, building a safety culture, and creating a system of organizational learning. Does this theory amount to a kind of a manual for safe operations of large, complex, and tightly coupled systems? Coming back to Sagan now, Sagan's research, I believe, is of value in this course in particular in several different ways. First of all, for you, he offers just an excellent example of a detailed case study analysis of a complex technology and organizational system, going into a level of detail, which of course you will not be able to do in the course of this semester, but using previously classified documents. He has, in the case of the Cuban Missile Crisis, almost a minute-to-minute chronology where he is able to identify areas where the system performed as described and expected, but also areas and incidents where it performed in an unexpected and potentially unsafe way. In fact, he identifies important system failures and near misses and accidents that could have led to much more catastrophic consequences. And in response to the previous question, does high reliability organization theory provide advice for managers? It does seem to me that his analysis here is instructive for managers, designers, and executives responsible for high risk, high complexity, high coupling processes and activities. It would be a good thing if the executives in charge of a gas plant or a nuclear power plant were to read this book in detail. And it is certainly an interesting effort at empirically evaluating high reliability organization theory and normal accident theory. During the Cuban Missile Crisis, he finds fairly disturbing evidence of incidents and actions which contradict the idea that the system of control worked perfectly and all of the safety systems were in fact completely implemented. Here's an important quote. During the confusion of this tense crisis, field level SAC and Air Force contractor personnel appear to have improvised their own safety procedures in a manner that seriously compromised Minuteman nuclear safety, the Minuteman nuclear-tipped rocket silos. He finds numerous consequential violations of rules and procedures in the arming and handling of nuclear missiles and their warheads. The incident which he describes at Volk Field in Wisconsin, really a kind of a fascinating, and if it weren't for the fact that it could have led to nuclear war, a kind of an amusing example, where an intruder alarm went off on the airfield. The intruder alarm was intended, the meaning of the alarm is supposed to be that there's an intruder on the airfield, but instead the klaxon went off, indicating an imminent Soviet strike. Pilots mobilized to their aircraft, the aircraft were rolling, believing that nuclear war had started. Fortunately, an official at the Volk Field made a redundant backup check and discovered that it was an error and that there was no incoming fire. Interesting to discover during the nuclear crisis, the Cuban Missile Crisis, again, I find these quotes pretty hair-raising. The only thing preventing a QRA, rapid response pilot from taking off with a fully armed weapon was a lone U.S. sentry armed with a carbine standing at the end of the runway. This is almost comical. President Kennedy, going on with the quote, President Kennedy may well have been prudent. He did not, however, have unchallenged final control over U.S. nuclear weapons. This is a deadly conclusion which Sagan has reached on the basis of this very careful study of the documents and sequences. And another false warning, the false warning of a definite incoming nuclear strike from Cuba to Tampa. Quote, a test tape had been inserted in the equipment, and at the same time, Moorestown, a radar station, had a pickup in the Gulf Coast area and became confused, called the Central Control and Display Facility, and reported the test target as real. This apparently real indication of an imminent nuclear attack, of course, had the possibility of stimulating a counterattack, and yet what it came from was a test tape. So false warnings can lead to accidents and can lead to escalation. So notice that the activities and systems that Sagan studies in the Cuban Missile Crisis are extremely large, extended networks of actors, different military services and commands, different countries, with European countries acting to some extent independently during the Cuban Missile Crisis, different and uncontrollable action by adversaries, including especially the USSR, the somewhat independent actions of intelligence services and the quality of intelligence which is provided, and conflicting beliefs and priorities within the organization. Sagan has found evidence of all of these kinds of sources of incoherence, lack of consistent management, which creates the possibility of devastatingly important error. So what are Scott Sagan's lessons? What does he draw from this? He comes down pretty much on the side of normal accident theory. He thinks that the optimism of high reliability organization theory is maybe overstated. He thinks, for example, that the idea of discipline in some organizations like aircraft carriers, that discipline leads to consistency and continuity, but it also leads to the possibility of substantial incentives for lower level actors to lie, conceal evidence, and compound errors. In fact, a strong organizational culture may lead to dysfunctional loyalty to the unit rather than to the purposes of the organization. And there is the implication that is implicit in the case study. In other words, we find instances of this kind of behavior, individuals behaving strategically within the culture and the rules within which they operate, and this sometimes leads to dysfunctional behavior. So Scott Sagan has identified a possibility which is more general than the command and control of nuclear weapons, but this is the possibility of conflicts of interest and priority within the organization, with different levels of the national security and military command, with different assessments of military threat, with Air Force generals believing, and high Air Force officials believing, that the imminence of Soviet attack was much greater than President Kennedy and his advisors. And with different levels of national security threat, this led to an inclination to act in ways that were at odds with President Kennedy's directives. But it also creates constraints on learning, because if the Air Force or if the National Security Council is interested in putting the best positive face for the public on a dangerous situation, this leads to a public story, a telling of the story that makes it harder to document and prepare the private story of what actually happened, but that then interferes dramatically with our ability to learn from the incident, and even more pressingly, it reduces the urgency of learning. If all went well in the Cuban Missile Crisis, then that implies we don't have a lot to learn, whereas if there were many, many places where that crisis could have gone off the rails, could have led to a nuclear exchange between the Soviet Union and the United States, then it is hugely important to know what the specific processes of communication, decision-making, errors at various levels, what that full story is. There is also, part of his skepticism is that the question of measuring safety is itself a contested question. Organizations, this is quoting from Sagan, organizations have stated goals, but they are also strongly influenced by powerful individuals, both inside and outside, who try to shape their goals and manipulate their behavior. And defining safety measures, or the measurement of safety, is often a strategically relevant action within an organization. And he makes the point about aircraft carrier safety, which is crucial to the Berkeley Group analysis, that he believes that frequency of aircraft measures during peacetime and routine measures is not a particularly good measure of aircraft carrier safety under wartime or conflict or crisis conditions. So the definition of safety, the definition of how we measure safety, may make a difference in the way that we learn and the way that we continually refine the organizational structures in which we try to manage these complex processes. I would conclude that Sagan's book has important implications for the management of nuclear weapons, and it is certainly a corrective to the public view that the technical and chain of command mechanisms governing deployment and release of weapons are all but perfect. He doesn't believe that command and control of nuclear weapons is all but perfect. In fact, his view is that this radically overstates the safety of our nuclear weapons system. And this view is shared by other analysts, including Jim Mahaffey, who's a nuclear engineer who wrote a very interesting book called Atomic Accidents, and he goes through dozens or hundreds of accidents, both military and civilian. But the book's conclusions are broader than nuclear weapons safety. The conclusions are relevant to other high catastrophe industries as well, including nuclear power, recombinant DNA research, and other areas where literally a whole nation might be affected by an accidental outcome. Maybe less urgent is the application of Sagan's ideas to more routine dangerous processes, where HRO theory provides, I believe, very useful guidance in hospitals, in the electric power industry, in the electric power networks and chemical plants, and other dangerous and risky, but potentially improvable areas of economic and industrial activity. HRO theory is probably a really valuable guide for improving safety in those industries. And that's not to say HRO theory isn't a guide also in control of nuclear weapons, for example. It's rather, we should maybe be more concerned about what the limitations of HRO theory are in those instances, because the risk of catastrophic failure is so much greater. So I look forward to the discussion we'll have on Monday, and thanks.